Please have a seat, Josh. The bell rang. So, Josh, sit, quiet. Hunter, notebook out. So, yes, do the first 7 derivatives of sine and evaluate it at 0. The phone's away. Balloon's already done. Here's your sine. Here's cosine. It's frozen. Yeah. Okay. Reset. So he says derivative of sine is positive cosine. Derivative of positive cosine. And Luke, how do we write fourth derivative again?
Just with the parentheses.
Parentheses and the number in it. And then we're back to sine, and the derivative of sine is
Bro is feeling himself. What's going on, bro? I did not do
that.
Yeah,
but it's going to put you to sleep.
Maybe we want to get
Okay, Marco, thanks for offering. What is negative cosine of 0?
-1.
Good job, Marco. -1. Marco, negative sine of 0.
Negative sine of 0 is still 0.
And what is cosine of 0?
-1. 1.
Positive 1. And derivative of sine at 0. Sine at 0. 0 and blah, 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 blah. Okay, so cool. This is we're going to do some Taylor series here. So this is finding the curviness, like the slope, the concavity, jerk, snap, crackle, pop, and then one pass. I don't know what. Fred. So I'm going to create a polynomial, not a sine function, a polynomial that I'm going to force the first 7 curvinesses to match. So the 7th derivative of my function, I'm going to force that to be -1. This was centered at 0. So the term I'm going to integrate with is just x, because x minus 0 is just x, yeah? So Luke, integrating this up, what is the integral of -1?
0.
Integral.
Negative x.
Negative x, and then plus c. How do I find c? Well, at 0, I wanted this guy to have the same value. So plugging in 0, what does c end up being, Arjun? So this equals 0. 0 equals -0 plus c.
It would be -1. I cannot think.
0 equals -0 plus c. What is c?
0.
There we go. Yeah. All right, Hunter, integrate up the 5th derivative of my polynomial that is going to mock and mimic the curviness of this. Integrate.
I'm going to say
Raise the power.
ln x.
Raise the power.
Oh, yeah.
What power is on this?
It's 1, so it'll go to 2.
Goes to 2, and then divide by the new power.
2.
And then plus c. when I plug in 0,
You get 1.
1 equals negative 0 squared over 2 plus c. That c is
1.
1. Cool. Josh,
Mhm.
next integral.
Negative x cubed over 3.
Negative x cubed over 3 times 2. Integrate this x, or sorry, this 1, which is x.
Yeah.
And then plus c, okay, I'm gonna stop writing it on the side here, but 0 equals 0 plus 0 plus c, c was 0. Yep. Charlotte integrating to get my third derivative.
Negative x to the fourth over 3 times 3x.
Integrate
X squared over 2.
plus c, which is going to end up being negative 1. Utah, what's my second derivative for my polynomial going to be?
Negative x to the fifth over 5 times 4 times 3 times 2 times 1 plus x cubed over 3.
Over 3
And then,
times 2.
Over 3 times 2 and then it's minus x plus c.
And the c in this case is 0, so, all right. Tanya, first derivative. Integrate.
Negative x to the 6th over 6 times 5 times 4 times 3 times 2. And then x to the 4th over 4 times. Yeah. And then plus. Oh, yeah.
And in this case, the c is going to be 1, because when I plug in 0, all these terms go away. So Marty, in the end, what is my function going to be that behaves like sine?
If x is going to equal negative x to the 7th over 2 times 3 times 4 times 5 times 7, 3 times 6 as well, plus x to the 5th over 3 times 3 times blah blah blah, times x cubed over blah blah blah, plus x, and no c here.
The c became 0. It's not that it's not there, but it's 0.
Blah 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 blah.
So I've done this one on Desmos a couple of times, shown you, I'm like, look, I'm magic. You can create it with this pattern. Kinda cool. You're unimpressed?
I don't like factorial.
Well, but you see where it comes from.
Yeah.
Each time I raise the power, divide by the new power, it's creating the factorial. I just wanted you guys to see where it comes from. And that's why I didn't write 6 here. I didn't write 24. I didn't write 120, showing you why the factorial comes about. Okay, so that is a Taylor series. Centered at 0, so it's also called Maclaurin series. Created by, or I should say, published in stuff by Brooke Taylor. But I looked it up. There's record of it in like 700 years before this, so
No, it was all him.
yeah, it was,
It's been old.
Where was
All
your
by his
phone?
Lowe's himself.
Anyway, so I have today's packet of stuff, fun stuff.
Thank you, Ms. Pascal. How do people even derive things like this?
Why
So
do people-
complicated.
We're gonna do it.
Well, integration by force.
We're about to find out.
Likely in the field of Afghanistan.
Afghanistan.
Then I just Pascal, they need to know.
Okay, not enough packets? Were there extras? Did you guys send them back?
Yeah, I handed back with the only one.
Yeah, please.
And Anna, did you get one?
Oh, yeah.
Lucas
What
got a
does it
lot of
say
extra,
for
can you
homework?
keep it?
Finish 1.14.
For real?
Yeah, that's
It was okay.
So I want you guys to do the same thing that I just did.
That's it.
I'm not telling you what the function is, but I'm telling you the first several derivatives of some function. And I am going to force my polynomial to have those same derivative values. So, Marco, what is the fourth derivative's value of the polynomial that I want to make be the same? 72. So integrate each of these up so you get the polynomial.
You need to add another C every time, or just like.
It is a unique C each time.
Okay, so there's just like C1s.
Well, you should be solving for those.
Good reading.
So integrating 72 is 72x to the first divided by 1 plus c, plugging in 0 for x. Why? Because that's where it's centered. So negative 12 equals 72 times 0 plus that first c. That c value is negative 12. Strictly because I'm plugging in at 0, it explodes this one. So in each of these, this does end up being my c value. So integrating up again, 12x cubed minus 6x squared plus 2x, and now the plus c is that. And then the last integration, Peter, what do we get?
3x to the 4 minus 2x to the 3 plus x squared minus 8x plus 2.
Cool. That's the process. So I want to show you a pattern. Had I written it out differently, you would have seen the factorials better. I'm going to do this one in reverse. Okay, let's see. Because normally with those polynomial things. All right. I have my term x to the 0 over 0 factorial plus my first derivative x to the first over 1 factorial plus my second derivative x to the second over 2 factorial plus my third derivative x to the third over 3 factorial plus the fourth derivative x to the fourth over 4 factorial. I didn't have to do all the one at a time. Does this come out to the same thing? What is 0 factorial?
1.
What?
1. It's every.
It's one?
Yes. Yeah. It's
Why?
It's
Okay.
It's 1.
So
There is
the
one
mind
way
was
to
paying
say,
attention
I
to,
abstain from voting. I am not playing in that game. We don't care that you're going to Aruba or Barbados or whatever. You can just say, I am not going there. One way to say no. So this all becomes 2 minus 8x. 2 divided by 2 factorial. 2 factorial is 2 times 1, which is 2. That reduces, so plus x squared. 3 factorial, 3 times 2 times 1, so that's 6. Negative 12 divided by 6 is negative 2. X to the third. 72 divided by 4 factorial is 3. Did I get the same thing?
Mhm.
So at the bottom of your page, where it says this thing about, hey, do you notice a shortcut? Is there a way to get these values? So if you wanted to find just one term, which they will ask you, or that nth term, the fifth term, or the term with an x to the fifth on it, I'm going to write it in off-center. So we wanted the nth derivative evaluated at whatever center you had, and it will be x minus the center to that n divided by what? N factorial. Nifty, Utah? Yeah. High level of niftiness. Spectacular. Hunter, good?
Good.
So there it is, that's all it is. Do the derivatives of whatever crazy thing, sine, tangent, log, natural log.
Alright, chapter 9's over.
Yeah, chapter 9's over.
That's it. That's it, boys. We're ready for these.
Not yet. Straight.
You actually know quite a bit. Okay, we did this one yesterday with series. How did we do this yesterday?
We knew 1 over x plus 1 in that series, and we knew that the integral of that is ln x plus 1. So we tried to integrate the series of 1 over x plus 1, and that's the series for ln x plus 1.
Okay, so Hunter says the relationship here, we knew how to deal with 1 over x plus 1. What is the relationship? Well, that's the derivative. So if I do the derivative, that looks like this geometric series thing. I can generate the series, and then he said that that's the derivative, so integrate it. So this should be x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, dot, dot, dot. Okay. In your packet, see if you can create it using the derivatives. So you guys do the derivatives down, plug in the 0 value, and get a polynomial. Which we already know the answer. I want to know if you can go the long way. So this is in the packet.
Accidentally had extra.
So Charlotte, Mario, just letting you know, Josh
That's
is
my
like all
fault.
about like just keeping them for himself.
Yeah.
He's like, oh,
He needs those notes.
He misunderstands how the exam is curved and thinks that if he takes us out.
That's a fair point. Like,
Good, better,
the
much
smartest
chance,
people,
actually.
and you've got a better chance.
That's a
The
very
thing is,
interesting
it's-
technique.
the thing is, it's
Okay,
curved
this
on a
is being
national.
recorded, but
Yeah,
you
so you
want,
take out the smartest people.
Yeah, we're good.
Don't worry about
we're slandering a demographic.
Oh, I love
it. But we're making
The
fun of
rest-
Alabama.
The rest of the nation is also taking the test. We outdo them.
Yeah, we did.
Just saying.
California sucks.
Like that
Beat
state.
Alabama.
Does AP give
Not
us
that
like
state that has a
Just
bunch
a
of
little
eyes.
Mid-Atlantic tribes,
Yeah,
So my
the state with a bunch of eyes and S's, we get
My
to.
favorite pastime is touring. So.
But if you take it.
Just do this.
Yeah.
Just do this. Just do this.
I could be more. I am from Mississippi, but I think.
I think you can do.
I had an 8th grader take my test once.
It's just.
How do you do?
No,
She got one.
Oh, that's right.
Local miss. She's now a senior at Blair. Why was she in my favorite take the test? Still man.
That answers.
That must have been fun to
Answers.
see like how she was during the test.
Makes sense.
Like,
I don't get this. I'm not allowed to be around.
I wish I could have.
So do you guys agree with the stuff that I have up, or are you not finished?
I didn't do
That's a very
this
meaningful.
one.
That's a great. I think the scribble is very representative of my mind right now.
Mine too, but I don't have to. It's the benefit of being a teacher. Do the derivatives, plug in 0, get those values, then integrating up. I get that. And again, yesterday the way we did this was after this first derivative, we're like, hey, that looks like this. So the derivative there, if I generate that series, 1 minus x plus x squared minus x cubed plus x to the 4th, blah, 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 blah. Integrating up, x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, da, 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 da. Do I get the same thing? It's written in a different order, but are all the terms the same? And if I did more derivatives, I could have gotten more here. Get it? Get it? Kind of, sort of? Is neat? No? Josh is feeling all self-conscious.
I don't exactly know how you use this. Like, where would you take? Like, from what do you take
Okay,
the information from?
so first of all, just integrating. You're okay with this?
Yeah.
And then, are you okay with this thing that we did yesterday? Hold that up.
How do you feel about
Reader Zane. So there's no official homework. If you didn't finish all of the packet from yesterday, the 9.1 packet, it should be done. Check your answers on Canvas, they're posted.